Part 2, derivatives of logarithmic functions. Okay, this one's going to be a little longer than last time, sorry, but that's okay. As we start our discussion of differentiating logarithmic functions by first differentiating the special function f of x equals ln x. Recall that can be written, or ln x can be written as log base e of x. And we're going to use our previous knowledge of y equals e to the x to help. Okay, now remember the derivative of e to the x was just e to the x, and we had to worry about chain rule. All right, so we're going to start off with this, y equals ln x. Okay, awesome. So that is log base e of x. Okay, and then when we rearrange that to exponential form, the e is the base, the y is the exponent, so we get e to the y equals x, which is what I've got written there for you. Okay, now we implicitly differentiate the above function with respect to y. Okay, and we end up with, okay, now I know what I've written here, okay, but let's just, okay, so the derivative of e to the y is just e to the y, and then we have to chain rule that, and we get the y prime, which of course is dy dx. Okay, and then the derivative of x is just 1. Okay, well, easy enough. So then, of course, we divide by ey to the y. Okay, so then y prime is equal to 1 over e to the y. Well, the thing is, now if we look back up here, okay, e to the y was x. So then y prime is just 1 over x. Awesome. Okay, so that's what I've kind of written down for you here. So dy dx, or y prime, is equal to 1 over x. So again, all of that long work to just get the derivative of ln x is 1 over x. As always, the chain rule still applies. So if the ln part is anything that has a derivative other than 1, then we just have to multiply our function by it. Okay, lots of practice here. Okay, so let's differentiate these. So, okay, x ln x. So this is a product rule again. So the derivative of the first times the derivative of the second. Well, we just learned that the derivative of ln x is 1 over x plus the second times the derivative of the first. So the derivative of x is just 1. Now, there's some really neat things that happen with this. Look, x times 1 over x, the x's just cancel, so you get the derivative is 1 plus ln x. Okay, and that's it. Awesome. So b, we use the chain rule here. Okay, so ln of this part, well, that's just the derivative is 1 over that, x squared plus 2x minus 5, and then we have to times that by the derivative of this, the derivative of the inside the brackets part. Okay, well, of course, that is 2x plus 2. Now remember, that's a fraction over 1, tops times tops, bottoms times bottoms, and you end up with 2x plus 2 over x squared plus 2x minus 5. And there is your derivative. Awesome. Okay, C is a little funnier. So we have ln of cos x. So the derivative of any ln function is just 1 over that function. So 1 over cos x. And then we have to chain rule the cos x. And remember, the derivative of sine is cos, and the derivative of cos is negative sine. Always like to write those. So the derivative of cos is negative sine x. Okay, well, that's going to be negative sine x over cos x. Well, wait a second. Sine x over cos is tangent, so this is, so f prime of x is negative tan x. Awesome. There it is. That's it. Okay, if we try this next one, okay, well, the 4 still comes down in front, so 4 ln x cubed. Okay, then we take the derivative of the ln x, which is just 1 over x. Okay, the derivative of that part, and that works out to, oh right, the 4 and the 1 over x combined, so it's just 4 over x ln x cubed. Okay, and there is that one. Okay, this next one is a little bit tricky, but not too bad. Remember, we want to take the derivative of ln absolute x. Well, funny how that works is, remember, that's a piecewise function. So absolute x could equal either positive or negative x. So the positive version, so ln x, okay, the derivative of that is just 1 over x. Okay, and the derivative of negative x, well, that would be 1 over negative x. And then the chain rule of negative x is just negative 1. Right? The chain rule of positive x is positive 1. You could have put that up there, but we usually don't put positive ones in stuff. Look at what happens with the 2 negatives here, though. 2 negatives cancel, leaving you with just 1 over x again. So, oh look, they're exactly the same. So the derivative, f prime of ln x, f prime of x, is just 1 over x. Okay, that is really important for you to understand. That's on your formula sheet. The derivative of ln absolute x is just 1 over x still. Okay, that's really important for, not so much for this unit, but for next unit it is very big. Okay, and then the last one. Okay, find the equation of the tangent line to that curve, okay, at x equals 1. Okay, so we have to find the derivative, because the derivative is the slope of the tangent line. Okay, so the first one is a product rule. So that is the first times the derivative of the second plus the second times the derivative of the first, which is just 1. Okay, plus 3 ln x, so that's just 3 times 1 over x. And the derivative of 2 is just nothing, so we don't have to worry about that. Okay, this one's a little trickier because there's e to the x in 2 of them, but not in all 3. So we don't just get to combine those. We can do some nice distributing here, though. So this would be x e to the x minus e to the x plus e to the x minus 3 over x. And something really interesting happens here, because the negative e to the x and the positive e to the x, they just cancel. So we end up with x e to the x minus 3 over x. So that is our derivative, which is also the general equation of the slope of the tangent line. Okay, looks good. Now, from here, we know that the point goes through x equals 1, so let's figure out the rest of that. So y at 1 is equal to, okay, so 1 minus 1, well, that's just 0. Okay, plus 3 ln 1, okay, plus 2. So if you type that in, 1 minus 1 is 0, so this part is going to equal 0. Now, it just so happens that, remember the shortcut, ln is log base e, okay, of 1. Well, e to the what is 1? E to the 0 is 1. So this part here is also 0. So then y equals 2. So we have the point, or this graph goes through 1, 2. So now we actually have to figure out the slope of the tangent line. So the slope equals 1 times e to the 1 minus 3 over 1. Okay, so the slope here, 1 e to the 1 is just e. Okay, so e minus 3. So that's the slope. Okay, so then y minus y1 equals mx minus x1. So y minus 2 equals e minus 3 x minus 1. And there is the equation of the tangent line. So that is it for this part. Talk to you later. Call me if you need anything.